And we are back with a second example. Notice we're doing the exact same thing. We want to decide whether or not a given number k is a zero of a polynomial f of x. This time the number that we're using is 1, that's a positive 1, plus 2i. And I just wanted to go through this example because I know a lot of students tend to struggle when they see that imaginary unit there, I. All right, but remember, we just deal with it almost like it's a binomial, and once we see I squared, we replace it with a negative 1. So let's go ahead and get started. Remember how up here we placed a negative 1, which was the k, right outside of our synthetic division setup? We're going to do the same thing this time. So 1 plus 2i goes outside, and underneath here, well, we can check whether or not we're missing any terms, but I have degree 4, 3, 2, 1, and 0. So I'm not missing any terms. That means I can go ahead and list my coefficients. So 1, negative 2, 4, 2, and negative 5. All right, so I'm going to go ahead and bring down this positive 1 here. Okay, so we bring down the first coefficient there, and then we multiply. So 1 plus 2i times 1 is 1 plus 2i. Now, notice how I line this up. Okay, so this negative 2 is a real number. I want to line that up with the real part of this complex number. The real part is the part without the I. So I want to line up the parts that don't have an I. Okay, that just makes it a little bit easier to add. So when I add these two, I get negative 2 plus 1, that's negative 1 plus 2i. And since there was no I to add here, I just bring down a 2i. Okay, then we're going to multiply again. So the thing is, you may have to come off to the side to perform the multiplication. So 1 plus 2i times negative 1 plus 2i. And we just use the distributive property. So 1 times 1 is a negative 1. 1 times 2 is a 2i. 2i times negative 1 is a negative 2i. And 2i times 2i is 4i squared. But remember I told you, and you saw this a little bit earlier in the course, I squared is negative 1. So then this term becomes negative 4. And these two terms, 2i and negative 2i, they cancel one another out. And I have this negative 1 here. So negative 1 minus 4 is a negative 5. All right, so that goes right here. Okay. And then 4 plus negative 5 is negative 1. And then 1 plus 2i times negative 1, we can write that out. So negative 1 times 1 plus 2i, we just use the distributive property. So that's a negative 1 minus 2i. And that goes right up here. Negative 1 minus 2i. And again, we lined up the real parts. And so we have 2 plus negative 1. That gives me a 1 minus 2i. Okay, so let's go ahead and multiply. 1 plus 2i times 1 minus 2i. Now, these are conjugates, and hopefully you saw this at some point. If we multiply conjugates, a plus bi times a minus bi, we're going to end up with a squared plus b squared. So in this case, we should end up with 1 squared plus 2 squared. 1 squared is 1, 2 squared is 4, so we should end up with a 5. Okay, but if you don't remember seeing anything like that, let's just go ahead and multiply this the way we multiplied this one right here. 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is a positive 2i. And then here, 2i times negative 2i is negative 4i squared. But again, remember, I squared is negative 1. So negative 4 times negative 1 is positive 4. Negative 2i and positive 2i cancel. And we have 1 plus 4, which is 5. So the product of these two numbers these two, this one and this one, the product there is a 5. And so -5 plus 5 is a 0. Okay, so remember the last one, we said that -1 is not a 0 because we had a remainder of 6. Well, this time we actually have a remainder of 0. So we can say, all right, since the remainder is 0, k equals 1 plus 2i is, in fact, a 0. That's it. And that's what we're looking for here. Now, just keep in mind that if you're asked to decide whether or not a number is a 0, you should have an answer of yes or no, okay, or something that implies that. If I ask you whether or not k is a 0 and you actually write out the quotient and that's all you say, or the quotient here and that's all you say, then I can't give you much credit for that, and whoever your math teacher is probably won't either. So just be sure to read the question carefully and be sure to analyze your work and answer the question that's being asked, or make the decision in this case that you're being asked to make. Okay, so this is our decision. 1 plus 2i is a 0. All right, I'll see you guys in a moment.